everyone. Hi, this is Kevin. Today's topic for my group will be to the use of Kevlar in aircraft. And my name is Xavier, and my group members are Christy, Ethan, Jeremiah, and Norif. So I'll be going on to a brief introduction on how Kevlar is actually being made of. So Stephanie Alcoholic, born 1923, July 31. She graduated from Margaret Morrison Carnegie College of Carnegie Mellon University in 1946. So she was actually the first person who invented the first generation of sending fibers in 1965, or more known as Kevlar. So due to the demands of the DuPont company wanting to create super fibers, these super fibers actually possess extraordinary strength, and they actually wanted it to be performed in extreme conditions itself. So this is actually how Kevlar was actually being introduced. So what exactly is Kevlar? So Kevlar, also known as para-aramid, is actually a strong, heat-resistant, and lightweight synthetic fiber that possesses high tensile strength of 3,620 megapascal. It is classified as a thermoplastic. Reason being is that it is actually best used in a room temperature condition. So likewise, it is actually softened when heated and hard when cooled. So additionally, it's reversible and it can be shaped. This will be more further explained in the sustainability part itself. Application-wise for Kevlar is that it is actually used as a body armor, bulletproof vest, and helmets in the military industry. The reason being is that they have a very good high tensile strength and very good high resistance itself. So now we'll be moving on to the objective, and I'll be heading on over the slides to Christy.
The objective is to describe Kevlar as a material in aircraft. First is to outline the properties, sustainability, and suitability. And second is the principles of production and implementation of Kevlar. Next.
Kevlar, being an aromatic thermoplastic, possesses both strong covalent bonds in the fiber direction and weak hydrogen bonding in the transverse direction, hence exhibiting anisotropic properties. Looking at its structure, it contains strong intermolecular forces from hydrogen bonding between the electromagnetic attraction from the NH center and adjacent oxygen from the carbonyl group. This leads to its first special property of high tensile strength. Additionally, it contains pi stacking from the benzoaromatic reaction between adjacent chains, which causes the chains to interlock, increasing its crystallinity, henceforth the high tensile strength. Next. Kevlar also possesses the properties of high resistance, as there are existing interchain bonds, namely the hydrogen bonding between carbonyl groups and protons, that gives rise to the high resistance. Next.
Kevlar also has a high melting point and a high heat resistance due to its strong intermolecular interactions between adjacent chains. Moreover, it does not expand when heated and is resistant to impact and abrasion. With a low density of about 1.4 grams per centimeter cube, Kevlar is lightweight and has a high strength-to-weight ratio. These properties allow Kevlar to be applied to aircraft such as landing gear doors, wing flaps, and window frames. Because of its high strength-to-weight ratio, integration of Kevlar in aircraft is able to reduce the overall weight by 20 to 35%. As a result, the aircraft has a higher payload and increased fuel efficiency. Next.
Moving to the sustainability of Kevlar, the manufacturing process of Kevlar requires an abundant amount of sulfuric acid. It ensures that the insoluble polymer is continually synthesized and spun such that it is capable of producing a high tensile strength of 3,620 megapascals and high durability. Sulfuric acid is known to have detrimental effects on flora and fauna. Being non-biodegradable, disposing of Kevlar will fill up landfills and lead to material wastage. However, it is not toxic to aquatic life and poses no environmental hazard in a spill of fire. It takes approximately 200 days before Kevlar can be decomposed. Thankfully, Kevlar can be 100% recycled due to its thermoplastic properties. Companies such as Ballistic Recycling specialize in recycling Kevlar. During the recycling process, Kevlar is deconstructed into 3 to 6 millimeters fibers, where it can be respun, pulped, and repurposed into a whole area of new products. Even though the production process of Kevlar is not good for the environment, Kevlar is considered to be sustainable after production because of its ability to be recycled. As such, this makes Kevlar a relatively safe and reliable option for the use in the aerospace industry. Next.
In conclusion, Kevlar 49 is a preferred material in the aviation industry as it is resistant to abrasion and able to sustain high temperature due to its melting point. It's lightweight but 5 times stronger than steel, which results greater payload and fuel efficiency, but also cause negative impact on the environment by using sulfuric acid in the production. So one of the recommendations is to use carbon nanotubes and the use of multi-way carbon nanotubes as the secondary reinforcement. According to research, it will increase the Young modulus by 50%, therefore enhance the stiffness of the material, allowing it to be stronger and suited for the aircraft use. Thank you.